It's a kind request to all the audience to kindly settle down so that we can start our lecture. Good morning, everyone. It's a matter of immense pleasure for the Faculty of Science, Shri Lal Bahadur Shastri Degree College, Gonda, to start a new lecture series which is going to have the lectures from all the departments of the Faculty of Science. And as head of the department, chemistry, I'm feeling lucky to start this new approach, innovative idea of Principal Sir to start a lecture series from renowned scientists all over the world throughout the year. This is going to be our first and inaugural lecture in which we are having a renowned scientist, a kind-hearted, rural background person, Mr. Santosh Kumar Tiwari, who is a resident of Balrampur and now presently is working in Poland. So, with the permission of Principal Sir, I would like to start the function officially. For this, I would like to call Vibha from MSc Chemistry student to put a badge on the honorable guest. In that series of welcoming and honoring our guest, the keynote speaker of this lecture, I would like to call Rekha ma'am to present a memento to honorable speaker. All the dignitaries over the dais will help Rekha ma'am for honoring our keynote speaker. Thank you. Now, I would like to request Dr. Ravi Prakash Ojha to come over the stage and present a short to the honorable speaker. Thank you, everyone. Without wasting much time, since this is an academic seminar and we are much more interested in listening to the honorable speaker. But before that, I would like to invite Principal Sir to just give a brief introduction of the speaker to our audience.
Good morning to all of you sitting in front of dais. It is a matter of great pleasure and honor that my student Dr. Santosh Tiwari, who is a well-known scientist all over the world, and as per one data, he is among the 2% leading scientists of the world. So it is a great pleasure for Devi Patan Mandal. He belongs to Balrampur. In Balrampur, a region that having a notion that person belonging to that region are not intellectual. Just a region in the Gorakhpur Mandal as Padrauna, and in Balrampur it is Pachpadwa. Usually people say that you belongs to Pachpadwa, you belongs to Padrauna, and Mr. Santosh Tiwari has broken all these notions. Now, within a short span, he has completed his BSc with botany and chemistry, and later on he chose mathematics and then qualified, performed the MSc degree in the chemistry, and after that qualified GATE and completed MTech from IIT Delhi and PhD from IIT Dhanbad. Now he has published more than 90 papers. And dear students, if you are students of science, everybody knows the nature. World known research journal, and his paper has been cited by Nature. So now it is a great pleasure. Instead of all these things, he is a good person. He is a good motivator. He, his YouTube channel having thousands of subscribers. He is a good poet, good writer of a poem, and is speaking on the certain social aspects.
तो मैं गुरुदेव का बहुत बहुत आभारी हूँ कि हमारे जैसे नगण्य व्यक्ति को बुलाया और कहा कि आप बात कीजिए। तो इसके लिए मैं अपने प्रिंसिपल सर का बहुत धन्यवाद करता हूँ, पूरे कॉलेज के मैनेजमेंट का, और ख़ासकर स्टूडेंट जिन्होंने ये समय दिया है। तो टॉक about me, what sir told, actually always parents and teacher give a lot of wisdom and give endorsement to the teacher student, but I nothing deserve like that. I even second class in my BSc, I lost first class my BSc with 1 marks, and I got very bad number in an even back paper. So what you are seeing in all those movies, all those things, is it really happening? Yes. If you are a good person and want to work hard, intelligence is not a parameter that mounting you that you are going to become this or that. Second, I did my, you might be wonder, I did my masters in material science, did my PhD in mechanical engineering of the materials. That is why this I am working. So there is no relation of my 10-year work in the chemistry. So if I make any mistake, please accept my humble apology if I made any mistake in chemistry. But of course, I will not try to make anything. So let's start about this graphene. We all, I think, heard about graphite. Graphite is what known for? Anyone can tell me, especially physics, we will interact a lot of the physics guys. And what is the graphite? What is it known for? So it's first we will tell, it has a million and trillion layers. So before 1850, it was a physics rule where classical people is understanding. Physics classify, Newtonian physics is telling, in 3D environment, in 3D system, 2D system cannot exist. So now you can ask, what is 2D, what is 3D? So this is bottle. It has length, it has width, it has height. So anything that is helping, I am 3D, you are 3D, this square is 3D. But what is 2D in nanotechnology? If you have length, you have width, but if you have no thickness, means thickness we have to negligible mathematically, not according to physics. So that is why Newton, Einstein, they believe in 3D, because this our universe is 3D, 2D system cannot exist. But so I told that graphite is a million and trillion layers. What happens if you remove one layer? In our 10 standard, what we have, atomic weight, atomic number, we have taken carbon as a standard. Means whatever we are calculating, it is carbon is a standard. So here, if the million and trillion layer, if we have a book here, any copy, anyone can give me a copy. So suppose I have this copy. Now it is having width, length, and this. So it is 3D. But I told, okay, write 100 later on this without opening. What you will? You are fool. How can I write it? Okay, so please try to understand. This is the case become Nobel Prize winning story. What was the? If I told, write 100 later on it without opening it, what you will tell? Are you fooling me? What is the only thing we can write a letter? We open it, take the one paper, because letter is always individual. So keep in mind, I am telling letter, not page. So once you take this, open this and broke it out, this is only, the paper is having length and width, but there is no thickness. So that is this graphene. In 2010, NAWA, and Jem from the Manchester University got the Nobel Prize in this. Why? that we will talk about in this very that you can understand. Next, please. So what we are doing, that I told the some background, what is the graphene, what we are doing, we are making a different kind of system. We are we are making a different kind of 0D means 1D, 2D, 3D nano system. What is nano system? Any system having 100 nanometer scale. Now, what is 100? What is nanometer? We will in the next slide we will see, and then we will characterize it. Sorry. What is it?
Laser from the first top one, and you cannot change the slide from there. We are changing the slide.
Okay. So yeah. So this one molecular and the kilogram scale production and material for extreme. What is extreme? Means beyond 500 centigrade and pressure 10 megapascal are like that, like maybe oil industries, aerospace industries, and mostly atomic energy related things is a very high things we need. And then surface engineering. Nowadays this term is becoming very popular. IIT Madras, IIT Kharagpur, they are opened a new branch about this surface engineering. This is a new branch. It's a completely mathematics and it involves physics, so it always need a hybrid people. Please next. So we are how we are doing all those things. So chemical route, electrochemical route, electro spring, milling, hydrothermal. These are technical words. We will leave it and we go to the next slide. So now we understand what I am telling the for your convenience what is 0D material. We are always playing with our lab. So 100 nanometer in all direction. So if it 100 1 nanometer, it is not nanomaterial. It not be. If it is this 1D means length can be any, but this thickness, the tube thickness should be 100 nanometer less than. And like this is D and this is 3D system that I take the first example. So here you see, you can concentrate, it is having multiple layers. So if we able to remove this layer, then this transform to 2D. I hope you understand what is the 2D material. If you not understand, please raise your hand. Now you understand 2D material. So first criteria should be 100 nanometer less than. Second, length can be anything, width can anything, but thickness should be negligible. It is not mathematically, but we as an engineer we consider it like that. Next please. So now next story is coming, how nano is, why nano is too much interesting. Have you in your home you have saw the needle or injection? How many water molecule can put on an injection? Can any student tell me? 1000, 2000, 10,000, how much? Can you tell me? You have a needle, okay? You have a needle and you dip in the water. On the tip, how many molecules you expect? It means you are not doing science with the imagination. Science is not making the formula, making the things happen, getting good mark. Science is the beyond sheer religious imagination. You will have nearly 10 lakh water molecule. How much? 10 lakh water molecule on the tip. So that is why when you are taking any medicine, they are less than in mg. Okay, so that is why nano becomes. So this your ball is this nanometer and this your water molecule is 0.1 nanometer. So we are mostly playing with here to here. We are working on quantum dots, we are working on nano devices, nanotube, nano cells and nanobots. Now one interesting example is nanobot is, nowadays you are having just news that he got a cardiac arrest and immediately need the laser surgery or any advanced surgery. Now in United States and in California they have proven, they have these nanobots, they injected you and within some time both means now, so they will carry all the bad cells and keep it outside. So nanobots are becoming very popular and they are becoming the hope for the Mars survival that we will talk about. Next please. So Now in home, now you can ask, okay sir, why you are talking all those things? It's not related to me. Nanomaterial, how I deal with. But in every day in your home, you are playing with nanomaterial. If you have a kite, you go in for the patang. This is coated by the particles that's easily cut to the others. They are the nanoparticles. In your home, you have pans. This pan is very interesting. Oh, this is very, there is no oil if you do. So this is not the bulk material. They are not the 3D. They are coated by the nanomaterials, and these nanomaterial make it non-sticky, so you can consume lesser amount of oil. Another, this is cementation. Suppose you have classical type of, you have heard many things in an ancient, in the Qutub Minar and many where the even they are not corroding, but nowadays the steel are the getting corroded. That is the reason of how much the finer particle corrosion you can decrease. So what I want to tell you, the nanomaterial is not working beyond the planet, not beyond your city, but it is happening in your life, day to day life. Next please. So why quantum nanomaterial? Let's talk something physics. Why quantum nanomaterial become very prominent and whole world is working on? For example, in graphene, it's a world record. In within 10 years, 3 lakh articles has been published. This is the world record. In 10,000 on graphene, only 3 lakh articles published. It means it is having a lot of application. The simple things you can say, maybe in the 10 year, most of the consumable materials will be removed by the nano system. So what is the nanomaterials uniqueness? Size dependence. Nanomaterials means should be below 100 nanometer. Then quantum effect. We will talk about it. Physics person understand much better. Math people also understand good. Then large surface area. Then tailored chemical reactivity and enhanced physical reactivity, and then biocompatibility. So these are the uniqueness of nanomaterial. One example we can take and talk about. Suppose, please pay attention. Suppose 200 people can survive in this, and if we push 3,000, 1,000 people, what will happen? Everyone will feel discomfort. So let's come on the orbital Bohr model. It is allowed in 1, 2 electron, 8 electron, 40 more, 18 electron can survive. But if you start pulling more electron, what will happen? Electron will feel discomfort, and that is called quantum effect. Two quantum effects are that quantum entanglement and quantum restrictions. Restrictions means you force the particles to move in a smaller size, and that is why nanomaterials have the different property than the whole bulk material. Please next. The good example that I put here, you can ask it because you are not asking, so it's my duty to give you more example. Suppose you have this kind of, I given 3 type of tea you have to prepare. Once you put directly this ginger, one time this ginger, this time test ginger, which one will be more tasty? Right. Why? You make the particle size very small. If you making more very small, they can interact with the milk molecule, and once you drinking, they are very easily mixed with saliva, so you feeling very tasty. So that is our nanomaterial. We are playing with it. This is the bulk material, this is the micro material, and we playing with this material. As I told, 0.1 to 10 nanometer we are playing, and this is a very sophisticated lab required, and we have to devote a lot of time without any outcome. So there is a saying in Europe, if you want to become a scientist, you have to a good elephant. Means elephant nowadays there is no meaning worthless, but you have to supply a lot of food. Because nanomaterial in the early age, so you have to put a lot of money for the research. So that is why there. Another example you can in the medicine, I put it intensely. Suppose you have a kids, I have 5-year kids. You give this one, he will feel very bad. So, but he can easily take it inside. But if you guys, he start vomiting. Means smaller particle very much interacting with the other system. So whole idea of the nanomaterial is making the particle less than 100 nanometer. Next please. Yes. Yeah. Quantum restriction, as I told, is a very good question, and I told some very yeah, I understand what you are telling. You are, I think, telling what I understand. If you decrease the size, how the we are restricting electron, right? So what happens if you are keep cutting anything, you are making smaller the size. Smaller the size means you are also affecting the electronic property. You can understand like that. Suppose you have a balloon, better you understand. The same amount of you have, same amount have air, but if you start pressing, what will happen? Somewhere it other side it will go. Means the kinetic energy and potential energy, you are disturbing the system. So if you making smaller and smaller, electron get restricted to revolve in a smaller space. Sorry?
Properties will remain the same after reaching or cutting.
No, it is not. That is the classical physics. That is the that I told in a classical physics we believe that the size does not matter. That is called quantum Hall effect. If you are MSc student, you understand better than me. You ask the quantum people why the quantum Hall and exceptional quantum. Now there is a term exceptional quantum Hall and tunneling. What is tunneling? You understand? Suppose you have this bottle. So the one idea is you cross this bottle by this, but there is another idea, you drill this bottle. That is called tunneling. But tunneling is not considered in the classical mechanics. Only the quantum mechanics consider that you can tunnel it. Means this is the barrier. So you have what you have. Suppose it is a barrier, you have to go by this. Only route is in the physics. But quantum physics says no, there is no, just drill it. That is called quantum tunneling. So size also badly affect the electronic and molecular properties.
Quantum tunneling is like an hybrid if you talk about like physically.
Yes, the quantum tunneling itself talking on the size again, because quantum tunneling you cannot observe in the bigger system. If they are so that is why you are giving your own answer. Okay. Nothing. Okay, thank you. So we are talking about now. Once we are getting richer, India is also getting richer. We are fifth economy and going to become third big. And everyone I think have this. If I ask what is the meaning of HDR, can anyone tell me? No, sorry. High dynamic resonance. Okay, what is this? So you need very bright and livelihood. So you need a quantum particles. That is the Samsung introduced this. This paper itself got 1 lakh citation alone. So they introduced the Tsinghua University, China. They introduced this method, and the patent it got in the nearly 100 million euro, and they transfer the technology. So by using quantum dots, you can high dynamic resonance you can create, resolution you can create. So your eye will feel they are very lively. So that is the basic difference everyone we are buying in our home. So if someone is thinking that no, this nano guy is far behind than me, it will come 100 years. No, it is in your life. You have to think about it. So this is the real example that we are using in our home. It's a Samsung that I put all credit is to Samsung, but this concept is created in this Singapore University, then it's patented by the Tsinghua University, China, and they sell this idea. Okay, next please. So now we are talking the real physics. That is our students very genuine questions. He asked how we are making it smaller and smaller, but it's a classical physics. He is giving itself reply if tunneling is the real in a this nano system. So there is a one lecture, because in United States and in Europe we also have in Vedic time we have such kind of tradition of discussion. India is the leader of the thought provoking discussion in the Vedic time. But fortunately, when we become slave and we lost many things, even we start hating our culture. So in 1950, it's very good for the student and who are interested in nanotechnology and this especially quantum physics. There is one lecture happens when he in the fun told there is a lot of gap here in the fun. If you go the biography, he told there is a lot of gap in the inside, not the upper side, because at that time people are going in the moon and astrophysics are living and this Hubble microscopy, everything is rising. So this guy made the big statement, nothing to go upside, go below. So that make the father of all the nanotechnology. People started searching and cutting the molecules in a nanomaterials level. Before that, if anyone is studying, Faraday is already studied 500 nanometer, but he started all those things, and real nanotechnology started. Nanotechnology, nanomaterials, material science, this surface engineering, he started. And two things that I am talking about, only things are they are very interesting, guys: the quantum confinement and quantum entanglement. So quantum entanglement, I not understand. I even don't know anything because I am not a physics person. Physics people understand it. Even big scientists not understand properly to it. It's related to the astrophysics. But this I can explain that in if we are having capacity of 200 people, if I pull the 300 people, everyone will feel discomfort, means kinetic energy will increase, and then behavior of everyone will change. How? Into 300 people once come, sometime you feel good, after some time you want to evacuate. No, if close, but in the nanomaterial, close, door is closed, so you start interacting and making different kind of behavior. So these are two properties that is determining our whole nano horizon. Next please. So now we understand as I told, how to understand. This is in a real way I make for my students when we have lecture. Yeah, sir.
How does this quantum mechanical barrier reach with the size of the nanoparticle?
Yes, sir. There is a different parameter in which you are asking. There is a different properties. Suppose you are talking the kinetic energy itself, mechanical energy itself, sometime mechanical energy, mechanical parameters increase very high sometime. So in which constants you are asking? Kinetic energy, in most of the cases, electronic kinetic energy increase very high because surface area become very high. So now you can counter question. I can ask, so sir, how this surface area become very high? So very good example I have always in my eye. You have a apple and cut it small and just leave in the table. After 1 hour you will find a huge dust on the, but if the apple is not cut, you will not find any dust, only few dust are there, because this surface area is become very active. Now he is prone to attract someone. So once we are increasing size, surface area hugely increase.
Just only this parameter surface to volume ratio that will decide
This is one parameter that I told. This is one parameter. There is a huge suppose there is a quantum parameter, so that, but this is one parameter. Surface area increase very high. Okay, so what we are telling here, that this is having, now there is a two terms also we are playing with, quantum nanomaterial and quantum dot. Now again this is difference. So human and superhuman. Sapa telling this is a very intelligent guy, he is a very hard working guy. So same we are defining here, 22 nanometer, 20 to 100 nanometer nanomaterial. So here maybe quantum, this quantum construction here restriction may be applied or not. But once you are coming here 2 to 10 nanometer, then here it become very interesting. Please go to the previous, the TB slide that I shown. Yeah, one more. Yeah, this one. So very interesting here you see. This is the different material? No. They are the same material but the different size. That I am just willing to make you understand how size making the things difference. So this is the single things, cadmium, 1 nanometer, 2 nanometer, 5 nanometer and up to. So these are when you are varying the size, property of the same system in the same solvent get complete new physics you are. That is why it is called, we have to develop new physics, new chemistry, and especially new surface engineering for the nanomaterial. Our students, I appeal you that have a good attention here. This is the identical material, identical solvent, identical irradiating power, but different kind of color you are. That is the uniqueness. It's coming out this nanomaterial. Why? So it means by varying the size, many things you can change. Next, please go. Yeah. So here, so if the size is 2 to 10 nanometer, then we people playing and saying is a quantum dots. And if size is 20 to 100 nanometer, they are mostly any nanomaterial. These materials are very important for the biological applications. So it is believed when the Mars is come in the power and people start settling, and obviously they cannot reproduce and make human there. So 3D printer based on the nanotechnologies, they print heart from here, send they there, and they transplant. It is not my any imaginary point. You go on the NASA and even our ISRO, they have the 3D system that they are building. We can transfer, they can transplant this finger, any they can print exactly like that. That is called humanoid robots. Now, one question I will ask to my students: how many people is knowing about the Chat GPT and Brad and Gemini? Okay, you think that it will change your life or not?
Yes, sir, it will affect whatever we are getting, like mankind and job opportunity in the employment in India and also whole world.
Okay, but it is the social media information. It is not any, after just go 20 year, 20, 40 year, 50 year, when there was no crane, there was a big agitation in Mumbai and in Kolkata. Okay, stop this crane. We know we don't need it because we are the human. We lost our job. You know the Amazon delivery. You know Flipkart delivery is 10 years back they exist? No. Only post office you have. How many government is giving maximum in one city 2 postmen on 3 how many delivery boys roaming there? Don't say that the technology is going to change your going to eat your job. Yes, obviously it's going to change your job. Now you have to change the direction. So these are the, that is these signs.
Definitely the amount of the number of jobs are definitely because after the introduction of the technology, the people whatever he has the talent of person will definitely like the technology is right.
Appreciated, but actually it's a kind of political question. If you have a huge population, who is responsible to take care of you? So that is the America and Western countries are posing the question to the China and India. Who is responsible if you have 10 kids to take care? If change is happening, you have to adopt the change. So what I am telling, these materials making the system very advanced that we cannot imagine. For example, we need injections for the rapid recovery. These materials in a solid form much better, 100 times better than can save with the injections, because 20 nanometer, 10 nanometer in the history, this is not in the use. Now we are in the system that we can use it. Now, other question of your Chat GPT. Chat GPT is creating awareness that don't believe on computer. One day computer can replace you. So this is a kind of, for example, why you love your teacher? Because he give a next year information. Okay, in the MSc you will read it. In PhD you will do thesis. It means not teacher is going to replace you. Chat GPT or any new technologies are the prone to make the human endeavor in the good form. But if you are still happy that okay, I will become an engineer, I become a doctor, so maybe in 10 years, 20 years you will lose your job.
Sometimes it is the mentality or the thinking power of person.
No, that is political question I cannot do. As a scientist, what we can talk, we have to be upper optimistic. If we cannot think about what government is going, because we are very small entity, even we don't have any position in India, so I cannot say anything. But it's obviously, as a scientist, we have to think very, very good. We have to think that it has to be happen, it is probability, and it is a good possibility. So possibility, probability, and probability. So these terms should be in the science. We cannot a lawmaker. Once any person will be lawmaker, they can change. Okay, next. And next, please. Okay, so these are the things we are modulating. We are in our lab. We are making all those systems. We are also doing the theoretical works. Because theoretical work we are doing. So these are the system: carbon nanotube, carbon ribbon, carbon onion, graphene quantum dot. All those things. This is one of my best paper published here. So it's a very high impact journal. This paper is published, highly reputed, and we have presumed that how these material going to change the world in the energy sector. So we make a very good emphasis here with the British Cambridge University Professor Ju, and me and one other guy from Poland. So we make a prediction 50-50, 2050 we are going to lose nearly 5% of our land due to the bad material use. So if this paper, if anyone is interested, can go through this interesting paper. So we have predicted 5% land we are going to lose. Next, please. So this is our main research that I produced 2 PhD in this only, 2 PhD and 6-7 masters. My masters is, all my masters is doing PhD in Cornell, Michigan, in USA. There some is in Max Planck, Germany. My master students are doing much better than PhD. PhD people are getting good job, good money, but master students are much better than even I cannot think that what they are doing. So they are doing PhD. One very good student from Nepal, Raunak, Raunak Pandey, he did master with me and he is in Max Planck. He is working on the soft material that can replace the plasma. So he is working, he's a material scientist, he's a nice guy, very young, but a nice chap. He is working in Max Planck. So we working only mostly. Now one other thing, sir, please. Yeah, this one you can also you maybe think what this speaker is talking about, what is new in this. So suppose you have a graphene and you have an elephant. In one graphene sheet you can put your elephant. What is meaning of this? In the coming year, your car will be 10 kilogram or maybe 100 kilogram. Now again, a good question you can ask, sir, how can many people will lose the job? You know, in car, presently you have 20,000 parts, and nearly 600 to 700 companies are helping to make a car. But in EV, Tata Nexon, only 100, less than 100 parts. It means all companies is going to vanish. No, they are smarter guys. They are shifting there. For example, our Reliance. Reliance is very good in the petrochemical, but they are genius. They hired good IIT and Stanford people. They completely changed to the database. They are data, they are cloud computing. So now you are only talking petrol, Ambani petrol, and once you become young, they are the leader of the data science. They are leader of the cloud engineering. They are leader of the networking system. So we are not changing, but industry people are very rapidly changing and they are making money. So what I want to say here, this graphene or material, by using, you can make very light space, especially you can go in the aircraft. Aircraft is a very expensive and they take a lot of fuel. So if our car is, suppose our car is maybe 10 or more than that, if it is taking a lot of fuel, in the future if we are going to replace by the carbon fibers or those, so it will be very less effective fuel and the EV become very prominent. So these materials, we are working on the mechanical properties on these materials and we are modulating the property, especially the how to enhance the property. Till date, the biggest problem with this material, there is no industry to produce. Even we are not able to produce good material, but because we have a good funding, so we are trying to at the lab scale and we are some patent and all those we are doing. Next, please. So now, if our physics people, especially our professors, can make a good comment, the BBC is telling in the this is the strongest material that we are knowing the diamond. No, no, there is no diamond is the strongest material. This graphene guy is the world strongest material. So this is the modulus 1 pp. There is so huge. Any question, please? Okay, so this is the parameters. This is very interesting parameter. Anyone is interested in the football? So in 1 gram graphene, whole football ground you cover using this. So how efficient this material is? Okay, what is this? What I want to tell? If you have to cover in the there is a playground, you put the white bars. How many kilogram? Maybe 10 kilogram, maybe 5 kilogram. And this guy graphene, only 1 gram is enough to cover whole ground. So how much money you are saving, how many things. So that is the miracles. Of course, they are in the process of R&D, and it will come soon. When we become maybe old, they will be the part of our children's. Next, please. So now you understand, as I explained, this is the graphite. It is a multi and trillions layers. Scientists are trying to separate it from 1840, and they are trying. We have make a historical correction to the Nobel Prize. You can see this my paper, the Nobel Prize winner paper published. I make a comment and they accepted. They told that they are discoverer. I told that no, this is work is going from 1840, and they very happily accepted. They published correction, and this paper you can see is an interesting paper. Evaluation of graphene. It's my graphene and graphene oxide for industrial application, and so Cambridge University people they accepted. So what is this? This is graphite, simple stone. It's a million and trillion layers, not million trillion layers. 1 layer, the spacing between is 0.34 nanometer. So Newtonian and Einsteinian physics is telling no, this cannot exist in our 3D system. But now this system, with the help of substrate, we can remove it, and itself it can exist. If we have time, I can share an interesting example. When we become academician, then we have a vision of observing people. So once Professor Jem, who got the Nobel Prize, he was in his room and cooking with his wife, because in Europe and they cook together, no one can cook for him. So his child is rubbing this pencil on the paper. This guy, okay, what is coming by this? Everyone is knowing, but this is the Nobel laureate mind. What is coming out the pencil and why it is writing? Okay, oh, it is a million and trillion layer, means layer is coming out on the paper. He stripped, come in the lab, he make a silicon wafer, put on the this next please. This one. We will go. So he take the tape in the lab. He just run from the his kitchen and went to the. His thinking means, if my child is writing graphite is layer, means layer is going, not graphite is going. He came in the lab. He made these guys, the big guys. They taken from this and they tested. So they found miraculous. That is why they got Nobel Prize. And this is our paper that we have made corrections. So interesting paper, anyone can read. So what they have gone in the lab and they become very happy that now we can remove the layers by the technique called lithography. Unfortunately, we do not have any lithographic technique in India, and Sweden, Netherlands is leader, and even China is not having. So don't worry. So that is the chip technology hole in the Falcon and all companies, because of the lithographic technique. We don't have. So it is not only money; it's a big technology and R&D. So these guys, first time in history, they got Nobel Prize. This we will discuss why they will only got for the separation. Please go to the previous slide. Yeah, previous one. No, not previous. Yeah. So we are here. I am not out of time. Huh? Okay, thank you. So we are here. These guys are trillion layers, not millions. If I am million telling, I am wrong. So million, trillion layers, and you have to find 1, 2 layers. So people are doing, especially the organic chemists are the biggest people, the good mind. So they knowing it can be. So they are doing oxidation and all those. So go in the place next. So this is, now you understand, we are talking about pencil. James is realized we are not able to realize. You see how many layer in this? This is this to this nanometer, you know completely. This is mm, it is in our home, you can measure by the vernier calipers. This is the thickness of our pencil. I make it very simple, and if you and the spacing between this and this, so it is 20 lakh layers in your this, 20 lakh layers in the tip. So that guy is able, so that is why they got Nobel Prize, not for the separation, we will talk, to develop the physics. They not got Nobel Prize for the separation. They got, so in your pencil, how many layers? Approximately 20 lakh layers is there. And when we are writing, few layers, maybe 10,000 layers, 20 layers or 20,000 layers is coming out, and that is we are able to write. Okay, next please. So this is the method, and they got the first, it is called Scotch tape method. Scotland tape they use, so because they are smart guys, so they give a Scotch tape method, and these two people, one is Russian, one is UK, they got Nobel Prize for this. Now question is arises, especially question, student can make a good question, good punch. Okay, what you are telling, only for the separation they got Nobel Prize? No, they got Nobel Prize to develop the theoretical physics, because theoretical physics is one of the most prominent things to give the support. How? Because we have to run a college, we need a rule, because without rule we cannot. We have a body, we need a rule. So theoretical physics they develop, and they develop the theoretical physics and against to the Newtonian physics and Einstein physics. They told no, if particle is very small, there is new physics arises, and two-dimensional system can exist in three-dimensional. That is why this is the biggest, it is called the biggest breakthrough in the history of 100 years. So this is one of the biggest history in the material science, engineering and science physics, because they developed a new physics. Next please. So why, now one question we will, I will finish and go to, I will not take more time. Question, student can make a good, yeah, yes.
Sir, as you have said that he has separated or detected it from layer again, how he has done, like an experiment was there, or the mathematical?
No. This is simple. If you go, you can repeat it in your home, but you need electron microscope in IIT Kanpur. You take a pencil, you take a simple tape. Your tape you put on the pencil here, okay, and just put, and then buy a silicon wafer and put in the silicon wafer. Send to the IIT Kanpur. They will take 1,000, and you can find this layer. So it's very simple. Even in home you can repeat. So it's not a big science. Now, one question we will stop. There is a many. I will not go in the science much. Student can wondering, okay, what is my business to separate this layer? Why you are talking all those things nonsense? 20 minutes we will separate layer. We will make 20 nanometer. We will make 10 nanometer. What is my business? What to do with me? So please next. So this is your notebook I told, and teacher instructed write 100 letter, and your book is having 100 pages. You cannot write any letter. First, so condition is this is completely compact. So only option, if you remove the paper each by each, then you can not 100, you can write 200 later. If it is 2 pages, so both side you can write. That is called surface engineering. You removing the layer and making the layer for the different application, means making the space, more space in the lesser material in the simple way. That is why nanomaterials becoming very, very popular. This is one aspect, but there is many other aspects. Next. So this is the previous, in the 1819 people are trying to reduce, make oxidation and all those things. Next. And then they make this, and then they reduce it, but it was not work. Now they go in the last please. Now it's over. No, go in the last more. So the one, yeah, this one. Next. No, first one. Previous, yeah. So this is the last slide we will talk. This is a real application of graphene in the market. So please just have attention that it's for, so bendable phone, you can bend your phone. So Samsung is already in market. Thus next maybe 20 or 50, 16 iPhone is coming complete transparent. graphene phone, that is I am giving you 3-4 year back, 3-4 year period to the Google maybe file a claim on me. So this is complete, maybe 20 or maybe 18 earphone when will come, it will be complete transparent. It's our material, that is graphene used here. They have got patent and everything is, this is the, that is we call about the targeted delivery, because once we are taking medicine, they are going here, there and disturbing the body. So now the nanomaterials are, they can target only to the, that cells, particularly that damage. And also nanosensors. Nanosensors means suppose one is having hearing problem and he don't want to put any machine. So a sensor will be fit, he can see. Now maybe you have heard the Google and this Meta make a machine that now a blind people can see. So they use these nanosensors that can transfer. Even you have heard about the Neuralink. What you are thinking can be seen in the Elon Musk. Neuralink, you can go, now they can transplant a chip and all the come in your TV, means what you are thinking it will be outside. So that is, these are material. More example that we are working for environmental protection, carbon capture, molecular, all those things we are working for. And it's not only me, I have a good team, we have a good team. It's not my work, I'm presenting all those works, so it's not my work, but we are working in a group, and so different groups. We are 3D printing in one of the best things that is going to happen in last coming 2020, maybe 20-30 years is going to make change many industrial revolution. Please go go in the last. So these are my lab, above lab, what we are doing. 1 minute you can go, I can show the student. Please go, more, up, fast, up, sure. So here, what I was talking, you can live that the student is talking, sir, how can know? So it is your graphite. You can see any layer? No, it is a graphite. So we have did an experiment, it's a graphite, no layer you can see. Oh sorry, come please. Come please, that one. Yeah, here you can see many layers, and here you can see only one layer. So that is the same materials we are made, and we also got a European patent. Fortunately, it is with Hyundai Motors. I am part of 1.1%. That is 0.1% also commercial patent. It is mine, so that can be produced one layer in our methods. And I did this during my PhD, but we explore later on. Okay, let's go. So we sure that it can be happen. It is not only talking. Next to go. Well, last. What? Come. Next. No, there is no more slide. Okay. So leave it. Okay, so that's it. If you ask, maybe some slide is missed somewhere. Anyway, so if you ask anything, I will be very happy. And whatever I wanted to present is very general things. So if you want, we can discuss.
Thank you so much, sir, for the very nice and intellectual lecture. Now the topic is there for the discussion. Anyone can ask anything about the subject, about the slides shown with us, sir. No.